In this video, I'm going to give you a brief update on the game, and I'm going to walk you through how I implemented walking by sending down events from the server to the client. Let's go. Towards the progress. So one thing is the white lines are gone. I fixed that by just increasing the rendering size of the tiles. So I'm rendering the tiles 80 by 80, which caused those white lines due to a subpixel rendering issue. And what I'm doing now is I'm just adding 1 pixel to the width and to the height of every single tile. They are slightly overlapping, but they look fine. You can't really see it. I might switch to a canvas-based rendering approach later at some point, but I want to see how far I can get with the DOM rendering approach. Remember, what I'm doing right now is I'm essentially rendering all the tiles absolutely positioned on top of each other. The second thing I've been working on is this little inventory. It is not working yet. This is just a responsive little statically positioned menu, which will give the player access to the inventory, to the character screen, and to the settings. And the last thing, probably the biggest part, was the walking. I completely revisited walking because it was implemented in an inefficient way, and I'm going to show you in a second how it works behind the scenes. Let's have a look how walking works, and essentially how anything works where the player does something and the server needs to tell the player, hey, something happened in the world. And the main secret ingredient is called server sent events. In my opinion, server sent events are one of the most underused technologies in web development. They are sort of solving a similar problem WebSockets are, and people usually straight away go for WebSockets, even though if it's just about sending events from the server to the client, as the name implies, you can use server sent events. So we have a player at position x0, y50, and upon game load, the player makes a request to the server sent to the SSE events endpoint. This will open a event stream. Essentially, it's a long running HTTP request that is open in the background all the time, where the client can receive events that the server sends down. So let's have a look at this. Let's have a look at the SSE event endpoint. We're exporting a single function called loader, which takes a request and returns a response. This is a Remix specific concept. Remix is the framework I'm using here to implement my routes and handlers and loaders, but it works similarly in other web frameworks. So we have a required player here, which means the incoming request needs to be authenticated. There needs to be a player attached to the session. If that's the case, then we are returning an event stream. And the event stream, what it does is it's essentially built on top of a node event emitter. So we're having this client event service, which takes a player and returns a player emitter. A player emitter is something that kind of emits events that are interesting to that specific player here, namely the player that issued the initial request. And we're passing in this event callback to the node event emitter, which is something of type client event. And then we are sending it down the event stream. We just say event. This is specific to server-side events. And we are stringifying the event payload and putting it into the data field. The client event is a type that sort of defines all the possible events that the server can send down to the client. Thinking about it, it should actually be called server event. Anyway, currently we have 2 events implemented. We have player stepped and player attacked. So the events, they all have a tag. This is needed in order to find out later on what is the type of the event, because we don't want to look at the structure in order to determine the event. That's why we just have the typing of the event in a tag. And then we have like what player made the step, where did the player step, and whether the current step was the last step. That is the server sent event part, and every step is being sent down into this event stream. Now that we have the event stream set up, let's take action. I'm the player and I want to walk here, so I am sending a post request to actions with the payload type walk x3 y50, which means I want to walk to 350. In the code there is this handle click function where I immediately start walking, and if there is no obstacle on the target tile, I am using the good old fetch API to post this to the actions endpoint. I define this action type, which is a union type of all the actions that are possible throughout the game. An action is very similar to a command in the CQRS world. It essentially represents a player intent. So it doesn't mean that the player actually can walk there. It just means that the player wants to walk there. It's up to the server whether the player actually can go there. After posting that action to the action route, we receive it here. So again, this is an exported action function. We're taking a request and returning a response. First, we're retrieving the JSON body, and then we're requiring a player. So only players that are authenticated can do actions. And here we will have a huge if, else if, where we check for every possible tag. And if the tag matches the certain tag of the handler, we're just gonna call the appropriate service. In this case, if the tag is walk and the player can walk, we're gonna call the walk service start walk with player XY. So this is how we initiate a walk, and walking is a stateful process from the point of view of the server. In the server, we sort of have a set interval where we run a certain progress walk function every second. Every time that happens, the server sends the client an event of type player stepped with the new coordinates. This is how the event handling looks like at the moment, and it's quite simple. All it takes is this client event, which has the type player stepped or player attacked, as we've seen, and we run a little bit of logic on the client for each event. In this case, we check the tag, whether it's player stepped, and for this specific player step tag, we literally just update the player location and whether the player is walking, which is the case if the step was not the last step. Remember, it's all type safe, so we cannot get typos in the tag, which is nice. And Copilot should know, yeah, here it is. This is how we grow our list of supported events. We just add else ifs, and if that list keeps growing, we can optimize it by using some kind of a lookup table. One thing to note is that if we compare events and actions, you will see that there is some kind of symmetry here. So actions are things that the player sends to the server, and events are things that the server sends to the client or to the player. And events are named with the past tense. So we have player stepped, player attacked, as opposed to walk action. Now, events are facts that happened in the past, and actions are things that the player intends to do. Things that the player intends to do can still fail. So if the player wants to walk somewhere, that can still fail because that area might not be reachable. While on the other hand, an event is something that happened in the past, and the server just informs everyone, hey everyone here in this area, this player just stepped. That's a fact. This has an interesting consequence because it means that the event handler by definition cannot fail within the domain. So every event handler needs to be able to handle all the events. It could still fail with some database error or some connection error and so on, but within the domain of this game, it's not going to be possible to have like a not reachable error or something like that. That's actually a quite important distinction, and if you want to know more about that, you can read up on CQRS. Let's zoom out a bit and have a look at the whole thing. So first, we establish an event stream using server sent events. Then the player sends some actions to the action endpoint. And lastly, the server sends down events with a certain payload to the player. These are the three major steps in building this simple server sent event-based architecture. There is one major drawback to this approach. Imagine handling the click of a player wanting to go somewhere. If we don't start walking immediately, there's going to be some delay, at least half a second, depending on where the server is, between player click and the player starting to move. And that is super duper awkward. You can have a look at all of your MMORPGs. Even if there is some server delay, there is going to be at least a signal that, yeah, we received your click, we're processing it. We're going to check whether the player can actually walk there. And I'm doing something even stronger than that. I'm not going to just tell the player, yes, I received your click, we're on it. I'm going to start walking immediately. Since we don't know where the player is going to walk to, start walking is only setting walking to true, which means it's going to start this wiggle animation. And this little trick makes it feel so much more responsive. So I just found this little bug. If you spam click, then she sort of runs like me after a double Americano, like super efficient from A to B. I don't care about trees. To see whether I fix that, tune in next time. Thanks a lot for watching, and if you like this kind of content, please like and subscribe, then I'm gonna keep devlogging this game.